Okay, we've been having some technical difficulties here, but we are back with our live feed show. We are doing review of proportions. Proportions are basically equivalent ratios, and they can be used to solve a number of types of problems. So, your basic proportion deals with two sets of ratios, which really look like equivalent fractions. As you'll notice, in this basic proportion, there are three numbers and one variable. So in order to solve this, you do cross multiplication, meaning the numerator or the top of one of the ratios multiplied to the bottom of the other ratio or denominator. M times 36 is 36m equals 9 times 24, we have a calculator, so 9 times 24 is 216. In order to solve this, you divide both sides by 36, and 216 divided by 36 is 6. So m equals 6. That's your basic proportion. We can use this setup to solve a number of real-world problems. The first one we're going to do deals with scale drawings. A model of a race car is built where 1 inch represents 4 feet. If the model is 3.5 inches long, how long is the race car? So as we said earlier, we start off with two equivalent ratios. The first ratio we are able to get from the information they've given us. 1 inch represents 4 feet. And I always say when doing proportions, use the words to help you set up the proportion. 1 inch equals 4 feet. The model is 3.5 inches. That's going to go on the top of this ratio because I set this up with inches on the top of this ratio. It really doesn't matter whether I put inches over feet or feet over inches, as long as I lay out the second ratio the same way. So since I put inches on top here, inches here, and we want to find out x feet. 1 times x is just x. 3.5 times 4 is 14. In this case, there's no division to do like we had in the prior problem, because when we multiplied in the prior problem, we ended up with a coefficient, a number in front of the variable. Here we just have x equals 14. So the actual car is 14 feet long. We can also use proportions in problems involving recipes. Darren uses a family recipe to make hamburgers. He plans on using 1 1/3 cups of breadcrumbs. About how many pounds of hamburger does Darren need to keep the relationship between breadcrumbs and hamburger proportional? So we look over here, Darren got his secret family recipe from his grandmother, and she said mix 1/4 cup of breadcrumbs, I'm just going to use BC for breadcrumbs, with 1 pound of ground beef. I know fractions make you nervous, but I want you to see the fractions are not really that bad. Now, normally we would make a recipe based upon how much ground beef we want to use, but Darren is bound and determined he is going to use 1 1/3 cup of breadcrumbs. So the first thing I want to do is I'm going to multiply 1/4 times x, which is going to give me 1/4 x. 1 times 1 1/3 is going to give me 1 1/3. Now, because I'm using fractions, I want to try and make this a little bit easier for myself and use an improper fraction. 1 1/3 is 4/3. So the next thing I need to do, since this is 1/4 times x, I'm going to divide both sides by 1/4. And when I divide by 1/4, you might remember I do keep, change, flip. 4 times 4 is 16/3. Since I'm dealing with pounds, and this is really a pre-algebra problem, 3 divides into 16 5 times, and 1/3. So I need 5 1/3 pounds of ground beef if I still want to follow Darren's famous family recipe, or if Darren wants to use his famous family recipe. We can also use proportions when we're dealing with similar figures. Now, this is from a bunch of pre-algebra problems where the directions would have said at the top, these figures are similar. So looking at these, you can kind of tell that this, we're going to call this the length, and I'm going to call this the width. It really doesn't matter, but since this is longer and this is wider, those are the numbers I'm going to use. Once again, in order to set up proportions, you just need to think about the way the numbers relate. So on this first rectangle, I'm going to put it 16 wide by 30 long. And this is 6.4 wide by x long. Cross multiplying 16 times x is equal to 30 times, something wrong there, 30 times 6.4 equals 192. And when I divide both sides by 16, 192 divided by 16 is 12. So for these to be similar figures, this length is 12 inches. This can also be used, once again, we're using similar figures to solve a real-world problem, because during a storm, a tree snapped, as shown in the diagram. And you can see that that tree kind of makes a triangle. Now they are telling us that we are assuming that this tree and this triangle are similar. So for the height of the tree here, 15.6 meters, I'm going to decide that I see a relationship between that and the height of this triangle. So if this was, top here was this tree, this is my unknown, my question mark, is going to compare with this hypotenuse of 8. Once again, cross multiplying, 6x equals 15.6 times 8, 124.8. Once again, I got this by cross multiplying, one on the top, one on the bottom, and 124.8 divided by 6 is 20.8. The length of the snap section of the tree is about 20.8 meters long. And the last one of these that I'm going to do, which I really love, is conversions. I know lots of teachers teach conversions lots of different ways, but I can do this as a proportion. I'm going to actually just, in my mind, make this easy. I want to find out 2.75 miles is how many feet. And if I look it up, I find that 1 mile is 5,280 feet. Once again, I did miles on top, feet on the bottom. So x times 1 is x. 2.75 times 5,280 is 14,520 feet. And this should be a good review for you of how to use proportions to solve problems.